Have to beat them. Have to beat them. Okay. 3.8, here we go. So here's some questions for 3.8. We're going to do some of your homework questions. I'm going to start at 8. I'm not going to start at 4 because 4 is expansion. So the multiplying out, which I want to focus on factoring. That's what this lesson's all about. So you still have to do the questions from 4. But I'll start with 8 with some help here today. So factor each trinomial, verifying by multiplying the factors. Okay. So again, what we're looking at is the possibility that this may be a perfect square trinomial. So we look at the first term and the last term, and those are perfect squares, yes and yes. So what are those perfect squares? Well, that's 2x is the square root of 4x squared. So 2x goes here and here, and the square root of 9 is 3. So we'll put 3 there and there. Now this is a minus sign in the middle term, so chances are these, if they're both going to be the same, they should both be minus. Now a negative times a negative does give you a positive here, so that's good. And let's do a quick FOIL to check. So this is negative 6x minus 6x. That gives us negative 12x. Or if a is 2x and b is negative 3, then 2 times 2x times negative 3 should equal this number right here. And that's 4 times negative 3 is negative 12x. That's true. So you can check the FOIL method. Check with just the arrows like this, right? Outside, inside. Check those. Or you can do 2ab and check that. See if that works for this one. Questions about A? All right. B. Is this a perfect square and is this a perfect square? Yes, yes they are. So we're looking at possibly a 3 for a first term here and a 5n looks like for a second term. Okay? And then this is plus 30, so these are probably going to be plus and plus if this is a perfect square trinomial. And let's see if it works out. So 2 times, what are we doing? 2 times a is 3 times b is 5n. So that's 6 times 5 is 30n in a positive. So does that match? Sure does. So this is our solution here. Please make sure you're getting in the habit of, if you aren't already, in the habit of circling or squaring off your answers. I'm still seeing on quizzes and tests and stuff a lot of work, but nothing circled. So you cannot have 3 or 4 options for answers. You have to declare one. That's important. I need to know that you know what the right answer is. If you don't circle anything, then it's a bit up in the air. And if I see more than one answer there, you're not getting full marks. Okay? So it's the process, correct process, and clearly stating your answer, making sure the answer matches with a question and with units and with decimal places and like that. Okay? So make sure you're circling your answers. Some of you still are not doing that. Okay, any questions about 8A or B? All right, so you don't have to do B, but I'm doing B just for, and you get to do F, okay? I'm not going to do F. You have to do F. That's part of your, on your own. You can check the back of the book for the answers too. Question? All right, 10. Let's take a look at 10 here now. Leave some space if you got to do F yet. Let's look at 10 together. So factor each binomial. So this is a binomial. What we want to check here in this section is are these perfect, or are these differences of squares, right? Oh, did we verify by multiplying? I guess I didn't verify by multiplying. I kind of did the 2ab thing. So the up here, I think verify by multiplying is showing the check like, sorry, I'll just go back here. So that's 4x squared, right? Minus 6x, minus 6x. We did this in our head, but here would be official. Minus 12x plus 9, and that matches with the original question, so we're good. The other thing is, please don't circle the check. I have some of you on tests and quizzes doing this. Here's my answer. Nope, that's the question. Don't circle your check. Okay? This is the answer when you're factoring. Okay? Yes?
Could you do 2x minus 3 squared?
Okay, if you stated this as 2x minus 3 squared, that would be totally fine as well, you bet. Yeah, that's right. Either one is good. Good question. All right, let's factor these. So for A, I'm going to check to see if this is a perfect square and this is a perfect square, because I see it's a difference. So is 9d squared a perfect square? Yes. Yep. 16f squared? 16 is a perfect square, and this exponent on the variable is even. We talked about that yesterday. If the exponent is even, you can always divide it by 2. That means it's a perfect square, and it has a square root. So as long as these are even, all these are even, so all the variables are going to be perfect squares. Okay, so this is going to be two binomials, perfect square. 3D, we put the square root as the first term for the first term there. Second term, put the square root for f. And then for a difference of squares, we want to make sure the middle term is gone, so we need a plus and a minus for the middle term to cancel out. So that's how we remember that we need a plus here and a minus here. And then that should be your answer. Let's check by expanding. So we have 9d squared when we multiply it out first. Outside, negative 12 df. Oh, okay. Plus 12 df minus 16f squared. So we notice that the df terms that we would have, because we have different variables in the first and second terms, those are canceled off. So plus and a minus, they're done. So yeah, we just have 9d squared minus 16f squared, and that works out. So our final answer is this right here. Questions about that? Okay, show of hands. 1 out of 5 means I don't get this at all. 5 out of 5 means this is pretty easy. I could teach this to someone. I'm pretty good. Okay. A thumb. What's a thumb? Is that like good, or is that a 1? Like, it's not good. It's conflicting. That's very conflicting. Okay. So that's why we stick with fingers. Okay. And if you're a 1, just give me this finger, not the middle one. Okay. Thank you. I appreciate that very much. Thank you. Yeah. How are you doing with this? Oh, not good. Okay. Ooh, all right.
We'll say that one's a 0.
Yeah, we'll say that one's a 0. That one's a detention. Okay, I want a detention. I want study hall. I want to be kept in after school. And I want you to phone my parents. Yes, that's what that one means. Okay. Let's do B. Okay, let's do B. I mean, this is pretty easy. I know it's baby stuff, but let's do it anyways. So, two binomials. It looks like it might be a difference of perfect squares. It is. So the square root of the first term would be 5s. So that might be the first term in each of the binomials. And the square root of this perfect square, 8t, looks like it should be the second term. And then, of course, difference of squares, I need a plus and a minus. It doesn't matter which order the plus and the minus goes. It doesn't matter which factors is first. Doesn't matter. They both the same. I usually put plus first and minus second, I guess. We'll do a quick check here. So 5s times 5s is 25s squared. Negative, 5 times negative 8 is negative 40. That's going to be st. This is going to be plus 40 st. This is going to be negative 8 times 8 is 64. T times t is t squared. Those cancel each other off. I am left with this and this. Yes, this is my answer. Boom. Okay, and you factored by, you verified by multiplying the factors. Good? All right, moving on. Okay, so here's the two variable situations. So let's take a look at this. We ended the class off yesterday with this one. So 11a, okay, so we have a y term here and a z term here. So it looks like if we're going to factor this to two binomials, then we're going to have some kind of y term as the first term and some kind of z term as the second term. That's what that means. Because we have a combination of y times z in the middle. So what is the square root of y squared? That's just y. And now this 10, oh, this is interesting. So this is not a perfect square. So we know this is not going to be a perfect square trinomial. That's fine. These don't have to be. These are just two variable trinomials. So now what I need to do is I need to test some of the factors, right? 5 and 2, 10 and 1. Those are my factors of 10. So if I go 5z times 2z, is there any way that I can get a combination of, the outside multiplication and the inside to get me 7? So 2yz and 5yz, does that get me 7? 2 and 5.
Yep.
Totally does. So I've got the terms in the right spots. This is a positive, so that means that both of these either have to be plus or both of them have to be negative to multiply to a plus, right? Because this is a plus, they're both going to be plus. Okay? So we'll do a quick check before we circle that. Y times y is y squared. This is plus 2yz. This is plus 5yz. And this is plus 10z squared. If I combine all the like terms, I get 7yz in the middle. And does that look pretty good? That looks exactly the same as my original question. So here you go. This is my solution. Hurrah. Easy peasy, right?
Yep.
All right, moving on to B. So trinomial, I'm going to try and factor this. So it's going to be two binomials there. Now, 4w squared and 21x squared, they have multiple terms each, right? So 2 and 2 and 4 and 1 here. We have 3 and 7, 21 and 1. So we're going to have to play around with, and again, if you want to do decomposition, you can. I'm going to start to move away from decomposition a little bit. You can still do decomposition. And if you're totally lost on all this, you need to come talk to me again or watch another video. Decomposition might be a good thing for you to work on if you're totally lost on this. But again, what I'm going to do is I'm going to try 2w and 2w here. I'm going to try that first. And I'm going to test in my head some of the other factors for 21. So 3 and 7. So if I put a 7 here and a 3 here, that gets me 14 and 6. Does 14 and 6 somehow combine to give me 8? Oh, if I did 14 minus 6, that would be 8. Oh my goodness. Okay, so that's good. So one has to be a plus, one has to be a minus. I think I've got these terms now set in the binomials correctly. But I need a negative 8. So that means if I do a negative 14 plus 6, you see that? Negative 14, here's my number line up here. Here's negative 14. If I add 6, I get to negative 8. You see? So good to go. That's correct. So negative, here's negative 14 plus 6 gives me this. Now, I've missed something in the last part here. This is obviously x and x. Okay. All right, so now I've got the x's there too. Okay, so let's multiply. 2w times 2w is 4w squared minus 14wx plus 6wx minus 21x squared. If I combine all my like terms, I do get the original question back. That's the same as the original question, so that this is my correct answer. Good? Scanning the room, yes? Any questions about this? No, this is easy? Maybe not easy, but you're understanding it?
Yep.
Okay, good. Anybody? Oh, question.
When is the test gonna be?
When's the test going to be? Soon.
Wednesday or Thursday? Are you gonna be supervising?
All right, number 12, factor each trinomial. Which trinomials are perfect squares? Okay, so again, perfect squares have the same binomial multiplied by itself. So let's just see here. I'm looking at these. Those are perfect squares, so that it could be a possibility, right? And A would be 2x, and this would be 7y. So 2 times 2x times 7y. Does that give me 28xy?
Yeah.
4 times 7 is 28xy. Yeah, so guess what? This looks like it's going to be a perfect square trinomial. So I'm going to put 2x here and 2x here. I'm going to put 7y and 7y here. And then because this is plus and this is plus, these two have to be plus. And a quick FOIL, 4x squared, 7xy, or sorry, 14xy and 14xy gives me 28xy, and plus 49y squared. We're good to go. This is my answer. Which are trinomial perfect square? Yep, perfect square trinomial, you bet. Perfect. A is perfect. All right, we look at B now. Let's take a look at B. And this is not a perfect square, I see. This is. Is there a GCF I can take out? Because remember, you always want to check for your GCF there, right? Is there a GCF? Nope, doesn't look like it. No, no common term for 15, 7, and 4. So let's do our binomials, and let's see what we can do. So I'm going to try 5m and 3m. Just pick two factors, and again, you usually pick the factors that are closer to one another to start with. And then, so 4n squared. What if I did 2n here and 2n here? Now, does this get me 7 in any way? Let's see. 10 and 6. Oh. 10 and 6. That doesn't work, does it? So 10 and 6 doesn't get me a combination of 7 at all. Okay? That means I'm going to have to change something. So I can change maybe this one. Let's try 4 and 1 here. What do you get there? You get 5 and 12. Ooh, 5 and 12. I kind of like 5 and 12. Although, this would be 5mn plus 12mn. Or it would be negative and plus. So does that work? Because I need a negative here, right? So a negative here means one of these has to be plus and one of these has to be minus. So yeah, is this going to work to get to 7? I think the answer is yes, isn't it? So 5mn and 12, if I do negative 5 plus 12, so negative 5mn plus 12mn, that gives me 7?
Yeah.
Good to go. All right. So once again, we have 15m squared. We have negative 5mn plus 12mn, gives us plus 7, and minus 4n squared. So there you go. That didn't take too long. And that's our answer. Okay, so is this starting to move in your head? Everything's spinning well?
Yeah.
Everything's kind of starting to make sense? You can do lots of little checks in your head. You guys are pretty smart, so I think you should be able to nail the intuition there. Okay, I do have one more from 13. This is again just more review. So maybe I'll let you work on finishing up the rest of more of that assignment, and then I'll do this at the end if you need. All right, 13a. So again, you want to look and see if this is a difference of squares. Everybody paying attention here. This does not appear to be a difference of squares. It looks close, but what you want to remember is that you always check GCF first. So there is a greatest common factor here, isn't there? I can take 8 out, so I'm going to remove 8 as a common factor, and what I'm left with is just m squared in here minus 9n squared. Now I look and I see, you know what? This is a perfect difference of perfect squares, so I can factor this now. So again, make sure you don't forget about the 8, but here you're going to make this into 2 binomials. So this is going to be m and m, 3n and 3n, plus, minus. Just to be sure, to check, you've got m times m is m squared. Negative 3mn, positive 3mn cancel each other out. Negative 9n squared. So now you look again, examine each of these. Obviously you cannot factor 8 down any further. You don't have to write it in prime factorization. A single number is fine. You don't have any greatest common factor out here. This is not a trinomial. It's not a perfect square. Nothing. Difference of squares. So, and you can't factor anything out of here. So that's your answer is you're done. Okay. So the GCF on these ones, you have to make sure you remember to take that out if you can. All right, over here for B, I have a 2 as a common factor in all of these terms. So I take a 2 out, and I'm left with 4z squared plus 4yz plus y squared. So when I remove the 2, now I can look at this. Now can I factor this one? Well, this is a perfect square. This is a perfect square. 2z times y times 2 is 4yz. So this looks like it's going to be a perfect square trinomial. So let's try it. So I've got 2z and 2z, and I've got y and y. So let's just see if this is a perfect square trinomial if I write this twice. So 4z squared, I've got 2yz plus 2yz, here we go, plus y squared. So yeah, everything matches up, everything looks good. You pulled out a GCF, you factored a perfect square trinomial, 2 layers there, okay? GCF first always. Got it, good? Awesome.